Hi everyone, welcome to another video tutorial. Today we're going to be learning about plotting in Matlab or Octave. So let's get started. On my screen, I have Octave open with a blank.m editor file open in my editor tab. The first thing that I'm going to do is implement a few commands that are generally good programming practices. The first is CLC, which is going to clear our command window. The next is clear all to clear any variables that we're using every time we run our code. And because we're using plotting, I'm going to also implement close all. Close all will close out of any figures every time we run our code. So that way we're not overwriting the same plots and the same figures over and over. The next thing I'm going to do is establish an X vector. I'm going to call my variable capital X, and to capital X, I'm going to assign a vector 1, 2, 3, 4, and 5. Next, I'm going to establish a Y vector. I'll call this capital Y, and I'll assign 5 values that I'm just going to come up with randomly. I'm going to use 2, 10, 15, 25, and I'll use 101. Next, I want to plot Y versus X. So X and Y are the same dimensions, which is essential for plotting. We're going to be plotting the data points 1, 2, 2, 10, 3, 15, 4, 25, and 5, 101. We're going to be plotting our X vector along our X axis, and we're going to be plotting our Y vector along the Y axis. To do this, I'm going to use the plot commands. The first input argument that's accepted to plot is our X axis variable. In this case, that's capital X. The next variable that I'm going to type in here is capital Y. This is our Y axis variable. By typing X, Y, we're going to be plotting our Y versus X. I'm going to save our file and run our code using this gear icon up here. And you can see that Octave generates a figure. This is a separate pop-up window that will come up every time we're running our code. I'm going to drag the right-hand corner here to just make this a little bit bigger. You can see this solid blue line connecting our data points, and we do have those 5 data points, 1, 2, 2, 10, all the way up to 5, 101. Coming back into our code, it's generally a good programming practice when we're plotting to add axis labels and titles. So let's go ahead and do this. To add an X-axis label, I'm going to use X label. And I'm going to put our axis label in single quotations because this is a string. So I'll just call this X. For our Y label, I'll use Y. I'd also like to add a title. When you generally don't know what to title a plot, you can never go wrong by just calling the title our Y label versus our X label. So I'm going to call this Y versus X. Again, this is in quotation marks because this is a string input for title. Go ahead and run our code. And a new figure is generated with our X and Y axis labels and our title. We have our title up here, our Y label over here, and our X label down here along our X axis. Now, what if we wanted to change some of the formatting with this plot? The solid blue line looks nice, but let's go ahead and make this a red line. Going to close out of our plot. Plot accepts a third input argument. We're going to be typing in single quotations R. This R stands for red, and this is going to change our solid blue line to a solid red line. You can see on the figure that gets generated, we now have this solid red line connecting our data points. This is by default where Matlab or Octave will connect our data points together. Let's go ahead and just create circular markers instead of connecting those points together. To create circular markers, right next to the R, I'm going to type a lowercase o. This lowercase o will change our markers to circular markers, and it's going to also get rid of that solid line that's connecting the points. Upon running our code, you can see the new figure that's generated. I'll make this a little bit bigger. We have those circular markers and they're still red because we left the R in here next to our lowercase o. Now let's go ahead and add a dotted line connecting our data points together. Next to the O, I'll type a colon. This colon means that we want to add a dotted line. Again, I'll drag this corner and make this figure a little bit bigger. You can see that we now have a dotted line that's connecting those points. Matlab and Octave offer many different formatting options available, and there are a lot of them to remember. And if you can't remember them all, it's nice to come to the command window and type help plot. You can type help followed by any function name to receive a lot of instructions and good information on how to use that function. For plot, we can just simply plot x comma y, which is what we were originally doing. We can also add formatting options, which is what we're currently doing now with this FMT, stands for formatting. Scrolling down, we use the colon to use dotted lines, but we could also change those dotted lines to dash lines by typing hyphen hyphen instead of the colon. There are a lot of other line styles available. There's also some marker styles available. We use circular markers. You could use crosshairs, stars, points, and any of these options shown here. For different colors, we use lowercase r for red, but there are also other color options available. Coming back over into the editor, you might be wondering the order of r, lowercase o, and this colon. So I'm going ahead and move our colon to the very beginning here. So now I have colon r lowercase o. And you can see that by running our code, we haven't changed anything. We still generate the same graph. So it doesn't matter the order that we're doing these formatting options, as long as they're all here within those single quotation marks. We can also add some additional formatting in the form of properties. So I can change the marker size, the marker width, the line width. I'm going to do that with the fourth argument. In single quotations, I'm going to type marker size, and we're going to change the marker size. We'll make these markers really big. To make them big, we'll use the value 12. So here we have a property, we have marker size, and we have the value assigned to that property following the property. So we have marker size, comma 12. If I run the code, and I'll make this a little bit bigger again, you can see we now have really big marker sizes because we've changed that property value. We can continue on here to keep changing the properties. So we could also add like a line width. And let's hypothetically say we want to make the line width size 10. And if we run our code, we'll generate a new figure with this new property. You can see that line width really drastically changes the graph. 10 is a really large size for line width. But it's really nice to see that these properties are available to us to help us change with formatting our graph any which way that we might want to format it. And there you have it. This concludes plotting in Matlab and Octave. Thanks for watching.